Hello everyone. So thank you for watching this lecture video. So this is about sample problems from 191 to 200. So for this problem 191, we want to find this conditional values. So this xy, so xy have a bivariate normal distribution. So for this bivariate normal distribution, we have 5 parameters. Like for x, we have x, we have, let's say, we have mu and sigma, right? Mu 1, sigma 1. And for y, we have mu 2, sigma 2. And also between them we have correlation or covariance law. So we have 5 parameters. So they have some relationship, and so we know there is a conditional distribution like for y when x is fixed, x equal x. So these things follow normal distribution. So mean is this and standard deviation this. So we have some formulas, but this formula, the relationship or the formula is hard to remember. So for such a problem, for me, I just give up. And the chance to have such a problem is, I think, really, really low. Okay, so this is just if you remember, if you know the formula, then you can do easily. If you do not remember the formula, you cannot do that. Okay. Okay. So for this problem 2, okay. So problem number this one. So the things we put this x loss. This follow uniform distribution. So this is just from 0 to 2. Okay. So we have a deductible d. So deductible d. So we don't know this d, but we know these things. So the payment at least 1.20 is this. Okay. So so let's say, so let y as payment. Okay, pay. So we have this probability, this y at least larger than 1.20 is okay. So from here, from this condition, we can find this d. So let's find this d first. So the payment is at least 1.20. So meaning payment is from, let's say, so from 0 to d, payment is 0, or from here is x minus d, right? So this payment is x minus d. X minus d larger than 1.2. So such a probability is x larger than d plus 1.2. Okay, so this probability is because x follow normal or uniform distribution. So here denominator 2. So among the 2, so larger than d plus 1.2 is 2 minus d plus 1.2, right? So we let this equal 0.30. So we can find d. Okay. So let's do some little bit of math. We find d equal 0.2. Okay. So now once we have the d, so we can find the probability, right? The payment is at least 1.44. So P y at least 1.44, so equal x minus d larger than this, x larger than d plus 1.44, so 0.2 plus 1.44. So such a probability is so here 1.64, so 2 minus 1.64 equal, so here's 36, yeah. So such a problem is normal and it is easy. So for this problem, this is this lifespan, or we denote this as x. These things follow exponential distribution. So this follow exponential distribution. So we don't know this. So what is lambda? So we don't know lambda here. So how can find this lambda? So we have this condition, like the probability that it's exceed 4 years is this. So this means we know there's a probability like x larger than 4 equal 0.3. So from here we can find the lambda. So let's say that for exponential distribution x larger than a, this probability equal e negative lambda a lambda times 4, right? So here again, this is a useful formula, like x larger than a equal negative lambda a. Okay, so this equal 0.40. So we know this lambda, right? Okay, so we just need to solve for lambda. So here let's say, so for lambda equal 0.3. Okay, and this is negative, yes. So lambda equals this. Lambda equal negative for log 0.3. Okay, so we know density function. Density function is f(x) is just equal lambda is negative lambda x. So we just plug in lambda like this. So let's check which one. Okay, so we just check let's say d or e, right? So I think just e, yeah. Okay. Let's see. So here is some a little bit of math. Yeah. So what is the d or e? So here we just check this lambda x. So let's say what is lambda x? Lambda x equal like negative, let's say, so 1 log 0.3 x. Okay, so this equal like log let's say this equal ln 0.3 over x, right? Okay, so let's say so, and here also have negative, yeah. So this negative lambda x equal so here this log x over 4. So we can put this equal like 0.3 like x over 4. Okay, so point this equal, so what is, oh, we put a negative here. So here is ln 0.3 is just 0.3. Yeah. Okay. Okay. So I think this is easy, right? Yeah. So for this problem, we want to find the calculate model. So what is the model? Is like a density function. This point, the probability is highest. Okay, so we just find derivative equals 0. So let f equals fx equals us, the constant we don't, fx equals us. We just find derivative equals 0, right? So derivative equals 0. So we easily can find this. So find the derivative. Let the derivative equals 0. Like let's say the derivative, numerator derivative multiply denominator. So minus denominator derivatives multiply numerator. So let this equal 0. We can solve this equation. X equals 0 or x equals s. X equal 1 over 3. So we just pick this one, right? So this problem, same thing, find the model. So just the derivative equals 0, right? So let f equal x is negative x squared. So derivative equal, so derivative equals 0. So we just find the derivative. Derivative equal x derivative 1, so is negative x squared plus x is negative x squared multiply negative 2x, right? So this equals 0. So x squared cancel, so this become 1 minus 2x squared equals 0, right? So we can find x easily. So for this problem, we want to calculate the probability that the company's total cost. Let's think this. So we want to find this, total cost is less than this. So what is the total cost? What is T? So let's check what is the total cost. So the company, it says the company has 5 employees. So each employee has 0.8% probability no hospital admission. So 80% no cost, and 20% have cost, right? So if so here the cost is also depends on number of admission to the hospital, right? So okay, so the number, let's say number admission, this number n for geometry distribution. Geometry distribution is the mean. So geometry distributions parameter p. So mean is 1 over p, right? So 1 over p equal 1.5. So number of admissions thus. Okay, so each admission cost is thus. Then total cost should be like just multiply a the cost, right? So this is for each person. So we have 5 employees. So total cost is just like that, equal C1 plus C2 plus C3 plus C4 plus C5, right? So here C1 is the first employee's cost, and C2 the same. Okay, so we want to find T less than 5,000, 50,000. Okay, so let's check some cases. So here, if T total is less than 50,000, so we have this case. The case the one is each or no cost, each xi equals 0. So this is definitely less than 50,000. So what is such a probability? So this probability is no cost for each one. Right? No cost 0.5, like 0.8, so 0.8, right? Okay. So then here, second one, only one employee is not equal 0. Only one is not equal 0, so all other is 0. Okay. Okay. So for such probabilities, so from 5 we just pick 1, right? So this guy has some cost. Cost is 0.2, and the other guy no cost is us, right? So for cost, should it be less than 50,000? So this means this cost, this number of admission can be 1 or 2, right? Only this case can be 1 or 2. Cannot be 3, right? 3 is exceed 50,000, right? Yeah, each time is 20,000. Okay, so for this probability n equal 1, so we know what is n equal 1. So n for geometry distribution, so n equal 1 is equal just the p, right? So n equal 2. N equal 2 means the first one is q, second one p. So here, what is p? We already know p equal 1 over 1.5, I remember, right? Yeah. So p equal 1 over 1.5 or 2 over 3. So we can find this, right? So p, so this probability, this part is 2 over 3, so plus 1 over 3 times 2 over 3, right? Okay. So the third case is that we have two CI larger than 0. Okay. So which two? So we can have like from 5 with a pick of 2 people. They have a cost. And the cost this probability 0.2, right? So that's having 2. And the other one, other 3, no cost is 0.8, 0.8, okay? So this n, so here we have 2 n, n1, n2. So what is the condition for n1, n2? So the condition total cost will be less than 50,000. So each one is each is at least 20,000. So here can be, let's say, can be 2 or 0. Oh, no, this is already included. So here only this case 1, 1, right? Yeah, so only 1, 1. So this probability, so by now it's easy, right? So 1, 1 is the first one is 1 is just the 2 over 3 times 2 over 3. Okay, so the total probability just add them up. So this probability, this we want to find this probability. Now this problem, find this probability that the machine has so the has this thing happen. Find this probability. So here, giving that, so this is a conditional probability. So we just check this condition, right? So giving that, so let's check this. So giving that the machine has not had three malfunctions in the first 3 days. So we just put okay. So day 1, day 2, day 3. So the conditions is just like that. Okay. In the first 3 days, the machine has not had three malfunctions. So we just put like this machine works good or fail. We just say a good or not good, or fail or not fail. We have 2 cases, right? So this means like these conditions not has not had 3. So this case just not if. Just like here we say that can be like we just say not this case. Not this case. Can be like a good, all are good, right? And yeah, and one fail, like good fail. So one fail. Excuse me. Or 2 fail. I'm sorry. Okay. So it can be like a 2 fail. So okay, the good. And 2 fail can be this. And 2 fail can be this. So the condition is just that we just check those 7 cases on it. 7 ways. So this is the condition. Okay. So now let's let's check what is the probability we want to find. Under this condition, we want to find that it's so the male function is on the 5th day. So here, 4th day, 5th day. So this just means 5th day is 38th. Yeah. So here, no, this case. If we put F here, if we put here, this is not 31. So not this case, right? Okay. So we say this is not the case. And so for those one, so we should put it face to face, right? This is okay, like, and so if we already have two face here, then this face, this G, so G, this face, this G, right? Good, and this is good. Okay, so this is the probability. So we can find this is conditional probability. Totally is equal like those three those 7 ways is we can put this is the 1 minus or a fail. So fail is 0.43. So this is all this condition, right? So among this condition, how many satisfy this? So we have 5 cases. We have 6 cases. So this 3 is we should put there's a 4 F. So we have so this equal like 3 3. So okay, yeah. So how about there's 3 cases. So we have 3F. Yeah. So this is just we have these 3 cases. Those probably the same. F is 0.4, G is 0.6. So 0.4 happen 3 and 0.2. Not on 0.6 happen 2, right? And this is 3. Same, right? So we just multiply 2. Okay. So for this problem, we have this is 5 stages, and what we want to find, we want to find the probability that the patient is in stage 1. So we want to find the probability for stage 1. So the problem like this, it can be 0, 1, 2, 3, 4. So we don't know the probability for each stage. So we put this as P0, P1, P2, P3, P4. So we want to find those 5 numbers, right? So we just use the condition. Let's say so for this one, this condition, 75% of patients in the group have stage 2 or low. So this means P0 plus P1 plus P2, this equal 0.8 long 75. Okay, so then check a condition. Second condition, 80% have stage 1 or high. So P1 plus P2 plus P3 plus P4 is 80. So this actually means P0 equal 0.2. Okay. So then for check condition 3, 80% of patients have stage 0, 1, 0, 1, 3, or 4. So this means P2 is also 0.2, right? So we have those equations, and plus, let's say P1, P2, P3, P4 is 1. So what do we want to find? So let's say what do we want to find? We want to find P1. Yeah. So question is P1 equal what? So from here we can easily find P1. Yeah. So very easy, right? P1 equal. So the problem become easy, right? P1 equal 75 minus 0.2 minus 0.2. Yeah. So this problem is we want to calculate the probability. Calculate the probability that the car experience is the first failure in the last quarter of some calendar year. Okay, so this is like, let's say, so times like from beginning to end of 1 year, and 2 year, and 30 year, just like that. So this is we want to find the probability that the first failure happened here, last quarter, or happened here, or happened here, like this. Okay, so let's say, so we just check. Okay, in general, let's say if this is K, let's say K here, like so suppose this is K here. So happened from here to here. Okay. So this is K. So we just find this probability, right? This X between K to K minus 1/4. Right? So this is last. So K. So this is the last quarter, and we just summation. This K can be, let's say, start from 1 to infinity. Right? So we want to find this. So what is the X? So X, the time. So X, the time for experience the first failure is exponentially distributed. So this X follow exponential distribution. So what is lambda? So lambda, the mean is equal to, so means 1/lambda equal 2, or lambda is just 0.5, right? Okay, so for exponential distribution, so such a probability, so we have the formula, right? This probability equal E negative lambda, then this K minus 1/4, so minus E negative lambda K. Right? So here we just simplify. Let's say, so we can take this E negative lambda k. Take this E lambda k outside, so this equal E lambda 1/4 minus 1. Okay. So this is constant, we can take it out. So this means like suppose this is C. So we put this as C, and this actually this equals C. Okay, C equal E. So lambda is 0.5, like 1/2. So this is 1/a minus 1. Okay, so C numbers k equal 1 to infinity. So E negative lambda k. So this one equal, we just take E negative lambda outside. So this is 1 plus x squared. So with this equal just 1 minus E negative lambda. Okay. So here we use this formula, right? Let's say xk, k equals 0, so remember, k equals 0 to infinity equal 1 minus x. Okay, we use this formula, right? Okay, so we can put this, okay, so multiply E lambda, maybe just E lambda, so this become E lambda minus 1. Okay, so by now we can say this equal like 1/a minus 1, and E lambda is half. Okay. So for this problem, this is the probability problem. We want to find the probability that exactly 12 packages are insured. So let's say, so here totally we have 20 packages. So 7 are damaged. So this means like 20. We have 7 not damaged, 7 damaged, and then 13 not damaged, right? A good one. So we just split the total into 2 parts, damaged or not damaged. So here we just pick one, so until the fourth damage package is just covered. So we just pick a first one, then second one, like that, right? Okay, and so we just pick a first one, second, until the last fourth damage is just covered. So the probability that just the last one is 12, so this one is not damaged. Okay, and so from here 11 packages, we have 3D here, 3 damaged, right? And 8 not damaged, right? So we just want to guarantee this, like from this 11 we have 3D. So for first 11 we have 3D and 8, and then last one is 12 should be D. So such a probability can be like this. So here we say, so here the landing pickets or totally is, we just so from 20 we just pick 11. So this is all total possibilities. So we just pick 3D. So from 7, pick 3, and from this 13, pick 8. Okay, so the order doesn't matter, right? So this is guarantee like from this 11 we have 3D, only 3D. Okay, so now we just pick one more. So by now we have 9, right? So after pick 11, by now we have 9. So guarantee this one is D. So among these 9, how many D's? So we have 4D, right? Yeah. Okay, so this is problems from sample problem from 191 to 200. Okay, so we can stop here. Thank you.